Day 66 of doing a LeetCode problem every day until I get a job. All right, guys, day 66, another day, another LeetCode problem. I'm glad you're here. I'm glad you're sticking with it. I hope you're not losing any motivation. I hope you're not losing any discipline, guys, because we're just getting started and we have a lot more to learn. But with that being said, don't forget, guys, don't forget, bring a mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button for me, go ahead and smash that like button for me, guys. Then after you smash that like button for me, guys, go ahead and drop that bank emoji in the comments. I need all of my bankers to go into the comment section, go to their emojis, look for that bank emoji, and then go ahead and drop that bank emoji in the comments, guys, so we could grow this engagement and grow this page and bring more swift awareness to a broader community as a whole. Now, guys, with that being said, the part you've all been waiting for, the question. And today we have question number 2,462, total cost to hire K workers. The difficulty level is medium, guys, but don't worry. We're not going to let that stop us. We're still going to keep the solution as easy and simple to understand as possible. So because we're all learning and we all need a solution that we understand what we're coding. Now, if you want to understand the solution, first thing you need to do is understand the question. So let's get into the question and see what it says. It says you are given a zero index integer array cost where cost I is the cost of hiring the ith worker. You are also given two integers, K and candidates. We want to hire exactly K workers according to the following rules. You will run K sessions and hire exactly one worker in each session. In each hiring session, choose the worker with the lowest cost from either the first candidate's workers or the last candidate's workers. Break the tie by the smallest index. For example, if cost equals 327712 and candidates equals 2, then in the first hiring session, we will choose the fourth worker because they have the lowest cost. In the second hiring session, we will choose the first worker because they have the same lowest cost as the fourth worker, but they have the smallest index. Please note that the indexes may change in the process. If there are fewer than candidates workers remaining, choose the worker with the lowest cost among them. Break the tie by the smallest index. A worker can only be chosen once. Return the total cost to hire exactly K workers. So, let's look at this example so we can really break that down and see what it means, guys, but it's really not that difficult. We have the input, we have the cost, this array of integers, K equals 3, candidates equals 4, right? So since K equals 3, we want to find the 3 cheapest workers. If we look through this array, we could see that the 3 cheapest workers are right here, 2, 7, and 2. When you add 2, 7, and 2 together, that equals 11. That's why the output is 11. However, there are certain requirements that we have to follow because we have 2 and because we see 2 multiple times. So if you see a number multiple times, that means you start with the number that has the smallest index, which in this case would be this 2. So if you look at the explanation, it says we hired 3 workers in total. The total cost is initially 0. In the first round of hiring, we choose the worker from this array of integers. The lowest cost is 2, and we break the tie by the smallest index, which is index 3. The total cost is 2 plus 2. So in the second round of hiring, now pay attention, because in the second round of hiring, you'll notice index 3, 2 is gone. We already got that 2. A worker can only be chosen once. So remember, we already chose this worker, which means we have to remove it from the array or pop it from the array. And that gives us a new list or a new array of integers, and these integers have different indexes as well. The indexes change as well. But as we said before, we still want this 2. So now we're going to get this 2, and now the total cost is the first 2 plus that 2, which is equal to 4. Then in the third round of hiring, we're doing the same thing, but this time 7 is the lowest number. So now we're doing 4 plus 7. Because we already did 2 plus 2, that's where the 4 comes from. Now we're doing 4 plus 7, and 4 plus 7 is 11, which is the output right here, because that's the 3 cheapest workers, 2, 7, and 2. So let's look at example 1. The array is a little shorter. We should get through this a little quicker, but it's the same principles. K equals 3. We want the 3 cheapest workers. So the 3 cheapest workers is 1, 2, and 1. Right? We remove this one because it's the smallest index, which would leave us with this array. Then we remove this one because it's still the cheapest worker, and that leaves us with just this. Then we remove this 2 because it's the cheapest worker out of that array, and and so it'd be 1 plus 1 equals 2, which is right here, and then 2 plus 2 equals 4, which is right here. That's why the output is 4. So we just added 1 plus 1 give us 2, and then we're adding that 2 plus 2 to give us 4 because K equals 3 and we only need 3 workers. So now that we understand what the question is asking, we have to figure out how we're going to code this. And the code is actually not that difficult, guys. So get excited about that. The first thing we have to do, though, is we have to import collections because we'll be working with heaps. And if you're practicing on Xcode, you have to download the collections package before you can import collections. It's not that hard. It'll send you an error, and that error will tell you how to import collections. Now that we import the collections, first thing we are going to do is we are going to declare a variable called lower canned, and that is going to be equal to a heap of integers. Then we're going to open up the brackets for the parameters, and it's going to say cost 0 up to candidates. Then we're going to come outside that, we're going to declare another variable. This one's going to be called upper canned. Excuse me, guys, and that's also going to be a heap of integers. Excuse me. And just going to put the parentheses outside of that. Then we're going to declare another variable, and this one is called next lower. We'll set that equal to, next lower, we're going to set that equal to candidates. But we have some more variables, so we're going to put a comma right there. We're going to say next upper equals cost dot count. Then we have one more, so we're going to, cost count minus 1. Then we have one more, and we are going to say total cost equals 0. Now that we have those variables, we're going to come down here, we're going to start a while loop. That while loop is going to have parameters. Next upper is greater than, open up parentheses, next lower minus 1. Then we're going to come outside of those parentheses. We're going to say and next upper, next upper is greater than or equal to, open up parentheses, cost dot count minus candidates. Then we're going to come out here, we're going to open up our brackets, and we're going to say upper canned dot insert. Then we'll say cost, open up the array brackets. First we're going to open up the array brackets, next upper. And we're going to come under that, and we are going to say next upper minus equals 1. And that's it for the while loop. But then we're going to come underneath the while loop, and we're going to say for underscore n 0 up to k. We'll come down here, we're going to say if, open up the parentheses, upper canned dot count is greater than 0, and open up the parentheses, upper canned dot min question mark 0. We're going to come outside those parentheses but stay inside the other parentheses, is less than Then we're going to open up some more parentheses and we'll say lower canned dot min question mark 0. Then we're going to come outside those parentheses, and inside the other parentheses again, we're going to say or lower canned dot count equals 0. We'll come over here, we're going to open up some brackets, and we are going to say total cost plus equals, open up the parentheses, upper canned dot pop min question mark 0. Then we're going to come underneath that, we're going to say if, open up the parentheses, next upper is greater than or equal to, excuse me guys, I don't know what that was, next lower. Then we're going to come over here, we're going to open up our brackets, and we're going to say upper canned dot insert cost next upper. Then we're going to come underneath that, and we are going to say next upper minus equals 1. Then we're not done yet, guys. We're going to come over here and we're going to say else. Open up the brackets. We're going to say total cost plus equals, open up the parentheses, lower canned dot pop min question mark 0. Then we're going to come underneath that, and we're going to say if, open up the parentheses, next lower is less than or equal to next upper. Then we are going to say lower canned dot insert costs next lower. Then we'll say next lower plus equals 1. Then we're going to come all the way down here, and we're going to say return total cost. Now guys, let's run it and see how it runs, guys. Let's see what happens. And they say accepted, guys. First try, that's what I'm talking about. So let's submit it and see if it stays accepted, because sometimes it will switch up when you try to submit it. But then, oh, look at those numbers though, guys. Look at those numbers. 276 milliseconds beats 100% of users with Swift, guys. Now that is what I like to see, guys. And I hope you like to see it too. And I hope that encourages you guys to keep learning and keep staying motivated, because we're going to just keep getting better and better, guys. But hey, we'll be here today. We'll be here tomorrow again for another day, another LeetCode problem. I'll see you guys then. Peace.